Welcome back. It's Module 3. And this week we're going to be looking at some of the most fascinating information that's coming into educational psychology today. And those are things that are based in neurobiology, things that help us understand our truly amazing brain. Let's move forward here. In the old days, people tried to understand human behavior and human thinking by studying the outside of the human head. Notice these lovely phrenology bumps. And we have in this picture wit, tune, ideology, sublimity, hope, love of truth. And if we just knew how to read those bumps, so they thought at that time, we could understand what people were thinking about and how they were thinking and how they tended to think. Of course, reading the bumps on heads has long since gone out of style. But it went slowly. Early diagrams of the brain recognized that there were different kinds of functions associated with different parts of the brain, but here it's area of sensations, touch, pain, and so forth. Area of the higher mental faculties, the speech area. And truth be told, diagrams like this look fairly familiar to me because when I was a little girl, we would see diagrams of the brain that tried to map it out. Well, it sort of reminds me of the way people map out diagrams of cows by different sections of the beef, or a map, which would be a little nicer way to think about it, says my vegetarian self. In any case, we've come to understand that trying to associate an area of hearing or an area of higher mental faculties is simpler than the actual truth, as we understand it. As things went on, the labeling of the areas became bigger words and more general. The olfactory lobe and the hypothalamus and the occipital lobe and so on and so forth. But even so, people would begin to think, okay, what does the occipital lobe do? What does the parietal lobe do? And so forth. And then along came the fMRI machine. People have used other kinds of machinery to get a sense of the electrical impulses in the brain. But the fMRI machine gives us several advantages. It looks at blood flow to different areas of the brain when people are engaged in different tasks. And so even though it's hard to do tasks in a tube, you'd be amazed at the resourcefulness with which researchers and potential research subjects have come up with ways to have people do different kinds of tasks inside an fMRI machine. There's even a study where they studied jazz musicians by having them play little plastic keyboards inside that tube. And they have to be plastic because if they were metal, the giant magnets would whack them up against the side of the tube. In any case, we can look at an fMRI machine and we can figure out which areas of the brain seem to light up, seem to get more blood flow during particular activities, and from that infer, and we are only inferring, that these are the areas of the brain that are most active. Let's move down. We can look at things in real time. These are examples of a brain when someone is talking, a brain when someone is tapping their finger. You see that little yellow area that's getting more blood flow? And here's an example. I hope my head isn't in the way here too much, of what it looks like when someone is listening. What's particularly interesting about these studies is that things get way more complicated. We come to understand that when people are engaged in tasks of any complexity, once we get past finger tapping, it's not just a single area of the brain that lights up. It's multiple areas, and multiple areas in some cases that tend to kind of hang together in a network. And when we start talking now about the ways the brain operates, we are more likely to be talking about networks as opposed to singular areas when we look at complex brain functions. In fact, there are 3 networks that we'll be talking about. I'm sure that as time goes on, we will discover more, and there certainly are subnetworks here. But we will be talking about the central executive network, or part of that is the executive attention network, and that's the area of the brain that helps you focus, that engages during goal-directed kinds of activities. Probably some of you have been at professional development when they talk about executive processing and how important that is. Well, there's, as you can see, multiple areas of the brain that are involved in that. The salience network helps us decide which of all of the millions of stimuli that are coming into our bodies at any given moment should be attended to. Oh, I'm getting a little text there. I hope that didn't show up on the slide too loudly. And to me, the most interesting of the networks is actually the one called the default network. This is something that we've discovered relatively recently, and that is that when the brain is not busily engaged in goal setting and tasks at hand and looking at things in the external world, there are important things going on relative to the internal world, and that's the default network. But be careful. We as educators and as a field have a long history of taking a little bit of brain research and translating it into a whole lot of practice in ways that are not necessarily justifiable based on the research. And so there's a whole series of writings about neuromyths and how we have to be very, very cautious about neuromyths and jumping to conclusions that are too broad and apply things too quickly. Nonetheless, this is fascinating stuff. At least to me, it's fascinating stuff. And this will be a wonderful introduction. At least I hope so. Talk to you again soon. Bye.